Hi class, this is Mrs. Albritton, and this is part 2 of the Algebra 1 Unit 3 quiz study guide notes. So this section of the study guide is the extra credit that I was mentioning earlier. This type of factoring we have not covered yet, but it's not that difficult, and I think that most students will pick it up in these notes. And if you do, you can actually try it on the quiz, and if you get it right, you'll get extra credit. If you don't get it, then don't worry about it. It won't count against you. So let's get started. So take a look at number 5. What is the completely factored form of the polynomial 16a squared minus 49b squared? This type of factoring is called the difference of squares. Difference of squares. And you can probably see why we call it the difference of squares. First of all, it's subtraction, and that's what difference means. And then it has squares, perfect squares in it. 16 is a perfect square. A squared is a perfect square. 49 is, and so is b squared. So therefore, it's called a difference of squares. And again, this will be an extra credit problem on the quiz. Now, let me give you the formula for factoring using the difference of squares. So the formula looks like this. If I've got a squared, some a squared minus some b squared, I will always end up with a plus b times a minus b. So this is how the factors will always look. One will always be addition, one will always be subtraction. They will never be both addition or both subtraction. And you see how I broke up the a times the a and the b times the b. We've always done it that way. Let's take a look at an example. Let's say we want to factor x squared minus 25. Well, when I break this into its factors, I've got my x times x. That's my first perfect square. And then 25 breaks into 5 times 5. And then remember, one will always be positive, one will always be negative, or plus and minus. And there, I've actually factored x squared minus 25 using the difference of squares because it is a difference and those are squares. Here's another example. Let's say we've got a coefficient in front of the x squared. So 9x squared minus 25. And again, we're going to break that into binomial factors. So 9 is a perfect square because 3 times 3. And of course, my x squared has to be broken apart. And again, 25 is a perfect square. It's 5 times 5. One's positive, one's negative. And we're done. And one final example. Let's try 36x squared minus 25. What if we've got a variable squared on the second term? And again, we're going to break them into binomial factors. So let's start with the 36. It's a perfect square, 6 times 6. X squared, x times x. 25, 5 times 5. And y squared, y times y. One is plus, one is minus. And we're done. Now, when we look at the problem here, so if we want to factor 16a squared minus 49b squared, I think we can handle that. We already know one's going to be plus, one's going to be minus. That's part of the formula, so that will always stay the same. And then I know that 16 is a perfect square. It's 4 times 4. A squared is perfect because a times a is a squared. 49 is perfect. We get 7 times 7, and b squared gives us b times b. And we are finished with that problem. Okay? And let's try the last one. Again, this is for extra credit on the quiz if you want to try it. What is the completely factored form of the polynomial 100x squared minus 25y squared? So let's get the two binomial factors. 100 is a perfect square. We get 10 times 10. X squared gives us x times x. 25 5 times 5, and y squared is y times y. One is positive, one is negative. And we are done. So I'm hoping that you will at least try the extra credit. I think you'll do okay. Bye for now.